the liquid oxygen. Then if that system fails, usually we have a backup system at the oxygen facility outside. We don't realize what happened, we don't feel any difference. That's done by our great engineering there. Okay? We don't have any hands to do that. We don't see any effect, everything's going on. As long as they have plan A, plan B. Okay? Usually plan C, the third plan will be departmental plan. So let's say some fire happens, something happened, we should have our own oxygen, like way to ventilate people and have, so whatever we are going to do today, it's going to be applicable on all gases. Okay, all gases are followed by the same physical laws. Okay, the gas will go from, try to go to the least pressure, trying to avoid resistance. Okay, so that should be, this is the main idea of what's going on. So that can be oxygen, could be air, could be vacuum, could be nitrous for OR. It could be anything that we can connect it through a system. Okay, in some cases it could be applicable for electricity. Okay, so how we are going to now the people today, or the coming project is to work on the plan B generator, air generator. They are going to do some maintenance on the one that hold the title of plan B. Whatever, we are not going on that complication, whatever their plan B is going to be under maintenance. So the hospital will be under plan A only. So we have to be aware about our plan C. Okay? You're recording, right?
Yeah.
Okay. So we're gonna identify. First of all, we're gonna identify what we are suffering from, which gases. So usually we have our black, white, yellow. Nitrous will be blue.
Yes.
All right.
Yeah.
Okay. Then, second of all, we're gonna identify which kind of standard of plug. Okay. Our hospital, this kind of plugs are called BIS, B-I-S-S, British something standard. I don't know. Okay. This is not the point. All right. You will be provided with the proper cable here. In this application, all the cables will be provided by me. So your part, every one of you will be responsible about one area, one distinguished area. So how we define which area is which area? Okay, we have to find the main valve. The main valve. In this department, the main valve is somewhere else. I'm gonna pause the video. Okay, ready? Let's go. طيب. So here in this department, we are at BICU. Our capacity is 20 bed. We look at the plan, all right? We look at the plan to identify the valves. Where this valves belong to? This valves belong to 11, 12, 13, 14, 15, 16. So it's belong to this section of the department. So we have 10 rooms. Our department capacity is 20. So we should identify the other valve. So we know this valve controls the oxygen for those rooms. We know that this valve controls the air for those rooms. We know that vacuum controlled from here for these rooms. Okay, where are the rest? Let's go and find. 1 second. طيب. So again, this is the part 2 of our arrangement of our unit here. It's 20 bed capacity. We see the gram here. It's saying 10 beds. The same arrangement: oxygen, air, vacuum. Okay. So in case of disaster, we're gonna identify where is our problem. This will alarm. One of these will alarm, and we will contact the maintenance. What's going on? They will tell us there is a huge things that they can. So we have to go to our reverse feeding plan. This is called the reverse feeding. What we are seeking. The whole plan is called reverse feeding. So if we decided that we are going to do a reverse feeding, first thing we have to shut down the unit that needed to be feeded. All right. So an example of oxygen failure: plan A fail, plan B fail, we have to do plan C, which is reverse feeding. I will come here, I will close this valve, and I will go to find the nearest socket. So for our example, we said that the oxygen failed, we shut down the oxygen valve, so we come to the oxygen inlet, and we are going to do what we are going to do on the other departments, same application. You're gonna connect the gas here. We're gonna do that at MICU, okay? We identify that we need to initiate the plan C, which is the reverse feeding. So I went there and they closed the air. I went to the valve and they closed the air from that location where we went. All right? So we're gonna test our air. So in the, let's say there was a delay. They call you until you get to know, so there was a delay. The whole network bleeded out. We are going to simulate if the whole thing went down. You shut the valve, the whole network of the hospital failed. So there is a lag time. Okay, we are going to put the longest lag time by emptying the network. Okay, I don't want any air in the hospital on this section. I closed it from there, but usually you don't want to do that. In the crisis plan, you don't want to empty that, but we want to add the air. But in this case, I'm going to show you the worst scenario by making the network totally empty. Okay? It's gonna take time to empty all the air from all this area. Okay? Well, it look like on our ventilator. Okay, we're gonna use that to see the drop. Okay? Instead of just emptying it, let's see the effect on the ventilator. This is nice. Sorry for the nurses, but this is, since we are here, we have to RTs.
பண்ணிட்டேன். They on already.
So we're gonna choose 40%. Let's say we're gonna choose 30%. Okay, we're gonna start our ventilation on 30%. Tidal volume 500. Okay, but I have the small test lung. I will look for a big one. Okay, okay. Let's start empty first. Less noise than this. Okay. One second. I'm gonna change it to because the tidal. This is not matching. Okay, so now 100%. There is no air. Okay, because I bleed it out quicker. The ventilator quicker than this. Okay, now we're gonna see if there is air or no. Okay, for RTs, this will be not matching this. The air supply pressure low. طيب. We're gonna see is there air, enough air. Okay. It's getting loose by minute, but this is the highest 50. The ventilator take around 60 and bigger number. We're gonna drop. Because yesterday we put the bin. Worst case scenario, okay? You have 0 liter air on the whole network of your whole department. This is the worst thing. Imagine if it's oxygen. You have 0 oxygen, okay? This is something serious, right?
Yes.
Yes. Okay, good. What we gonna do? We said engineered, they have their own one, plan B, failed. We are now plan C. What we gonna do? First, close the valve. Close the valve. Second, come to this part. Okay? This part is the beginning of the reverse feeding. Okay? So I'm going to connect this cylinder back to the inlet. Then this inlet will feed me, then this cylinder will feed my unit. Okay? طيب. Now we have our flow 0, we have N. Okay? So I'm going to do again the worst case scenario. I want to fill the whole network, okay? Then monitor the number by the ventilator, okay? So our ventilator now, if we connect it again, we will keep it because it's more precise on this. It will give us very accurate times. Air. We're gonna connect our ventilator to the nearest socket. Okay, so in the department, our department NICU, BICU, that we will have our distinguished room that we are going to feed. On this department, we said this is actually first not patient area, but this is, we keep this arrangement just for you guys to see what's going on. All right. So again, we will start our ventilation. Our ventilator will be saying 100% low pressure supply. All right. Okay. Again, we haven't connected anything. We are just seeing what our situation right now. Our situation now, I asked the ventilator to give me 4%, but actually it's giving me 99. The low pressure alarm is up, and we already initiated the crisis plan. All right. So you identify your valve, you closed your valve, then you come to your point of feeding. Your point of feeding will be consist of cylinder, regulator, hose. The hose will be provided by the RT. This setting will be provided by RT. RT will be responsible about this setting. But your responsibility is to do the following. You identify your valve, you do this. You get this valve, or this hose, put it on the one that I told you to put it on. In this scenario, I'm gonna put it on this one. This is where I'm supposed to put it. Okay, I'm gonna open. Okay, and we're gonna monitor our oxygen here. We will see how much our response time is gonna come back to 40%. All right, we started, we have time in the video, so we can monitor that very precisely this time. Okay, now this is going to feed the whole network of this department because again, physics law. The air will go to the least resistant. The ventilator now, it's the highest resistance. So it will go anywhere but the ventilator. Okay? So it will go everywhere first to fill everything until it's got blocked. Okay? So now we see our changes. Everything is back. This is called the lag time. Lag. How long our plan takes to come successfully back again. Our plan should be successfully back again when this is 40 and this is 40, or when this is 60 and this is 60. Matching FiO2. Why we should have matching FiO2? Because a lot of our disease, one of them your cardiology, one of them your ROPs, and it's not the matter of discussion this. Okay? FiO2 back again, and we monitor that. It's in very quicker manner time. Okay? Now our plan is complete. Whatever happened in anywhere, I don't care because I have my trusty cylinder. Okay? I have my hose. Okay? I have the knowledge to do the reverse feeding. Okay? So everybody now will be distinguished to his own inlet, and we're gonna discuss that out of the video.